Hey everyone, and welcome back to another tutorial from the Electronic Armory. I'm your Electronic Armorer for Android, and today we're going to take a look at taking pictures with your Android device and using that image in your application by displaying it in an image view. Let's get started. So to use the camera, Android SDK requires additional permissions from the user. We also have to let the operating system and other apps know which features the app is using so that it can be displayed in the Google Play Store, and also because other apps may need to know what features you're using. We tell the Android operating system that our app uses a particular feature by using the XML tag uses_feature in our Android manifest file. Some other examples of uses_feature is Bluetooth capabilities and of course our camera feature. You may also choose to use an additional Android required equals false for non-required features. So for example, if your app runs just fine without the camera, but you'd like to use the camera in your application, you can add the additional attribute Android required equals false to let the App Store know that if somebody has a device without a camera on it, it's still acceptable. If you don't put this attribute on it and somebody doesn't have a camera on their device, they won't be able to install your application. The next step we have to do is ask the user permission to use the camera. So the uses permission XML tag requests the permission that the application must be granted in order for it to operate correctly. Permissions are granted by the user when the application is installed, not while it's running. So we must declare the user's permission android.permission.camera in order to ask for permission to use the user's camera. Alright, now I'm going to show you the code that we're going to use in order to set up our camera and start getting images. So we declare the uses_feature Android name equals android.hardware.camera in our Android manifest file. We then have three sets of permissions: android.permission.camera, android.permission.write_external_storage, and android.permission.access_find_location. You may be wondering about the latter two permissions. Write_external_storage allows the application to write the image that the camera captures to your external storage. And finally, access_find_location allows Android to embed EXIF data into your photos. The EXIF data contains GPS location as well as time. And so we need to get find location data in order to do this. The way that we're going to launch the camera is using an intent. This is what we call an implicit intent because we're implicitly declaring our intent to have a camera activity. So to do this, we declare an intent as usual by calling new intent, but instead of passing it a context and a class reference to create, we're instead just passing it one parameter. In this case, mediaStore.actionImageCapture. We can also capture video this way by replacing actionImageCapture with actionVideoCapture. Next, we need to tell the camera activity where to store the image. We first need to get access to a directory that our app can write to. We have a static class with a static method called getOutputMediaFileURI, and we're passing it a constant mediaTypeImage. We'll show you the code here in a second. This method passes back a URI object which we store in file URI. We then use that file URI and bundle it into the camera's intent extra with a key mediaStore.extraOutput. This is letting the camera activity know where we want to store the file. We got the code from getOutputMediaFileURI from the following URL. We'll include the entire source code for this project in a link in this video's description below. Finally, we call startActivityForResult. We pass in the camera intent, and we give it a request code of 0. When the user is done taking a photo, onActivityResult will get called in our main activity. Check for result OK, and the results will be saved in the file URI if you added it to the intent. We can then create a bitmap image from that file URI by putting it into the bitmap factory. Once that bitmap is created, we get a reference to our image view, and we set the image bitmap to the camera bitmap that we got from our bitmap factory. Alright, so let's show you actually how to do this in code. Alright, so I've created a new project for our camera, so we'll have a button that launches the camera activity and an image view that will display the image that we capture from our camera. I'm first going to remove the Hello World text view. Then I'm going to insert a button to launch our camera intent and then an image view. Now we want our image view to take up the full width of its parent as well as the full height. Right now it's wrapping the content both on height and width, but there is no content, so its dimensions are 0, 0. To fill the width and the height of its parent, go over to Layout Width and Layout Height and change those to Fill Parent. Alright, once that's done, we have to give each element an ID so that we can manipulate it in code later. This one has an ID of ImageView, and that's fine for now. Alright, now that we have our interface set up, we have to set up the uses features and uses permissions. We do that in the Android manifest file, so let's navigate to that now. So this is our Android manifest file, and in here we're going to tell the Android operating system that we're going to use the camera feature as well as ask for permission. So let's put that in now. Okay, so here's our code to tell the Android operating system that we use the camera feature. We're asking for permission to use the camera as well as write external storage and access file location. Save that and let's go into our main activity. Alright, in our main activity we're going to set up the camera button so that when we click it, it has a click listener on it that will launch our camera intent. So we start by getting a reference to the camera button. Now that we have a reference to our camera button, we can set an on-click listener to listen for the click and launch our intent. Alright, here's where we put our logic for our camera intent. So we're going to create our camera intent. So this is an implicit intent, so we just have to pass it the media store's action image capture in order to launch our activity. Now that we've created our intent, let's get a file location so we can store our image at that location. We need to keep this file location throughout different method calls, so let's make this a class member. So to do this, create a new URI object called ImageFileURI. Now that we have that declared at the top, we can assign it a value in our onClick handler. But where do we get a file location that we can actually write the image to? If you remember, we have a media utilities class, and I modified the source code just a little bit so it works as a separate class. Let's go ahead and create a Java class file in order to use this code. So create a new Java class, call it media utilities, and I'm going to paste in the code that I have. Alright, we have some pretty simple code here, and if you notice at the top we have a media type image and a media type video. We'll pass in one of these two constants in order to see whether the file name has a .jpeg extension or a .mp4 extension. You can see that in the code below. In our getOutputMediaFile we pass in one of those constants, and in that method we call getOutputMediaFile, and we turn that into our URI. In our getOutputMediaFile, we get the external storage public directory so that we can write our image file to it. Once we have that, we store it in a file object, make sure the directory exists, and create a unique file name using a timestamp. Finally, we check the constant that's being passed in, either media type image or media type video, to finish off the file name. Again, this code will be included in the source code, and we'll put a link in the description of the video below so you can download the entire project. Alright, let's jump back to our main activity. And now that we have that class, media utilities, we can then get that file location. And that file location is going to be a JPEG image, so we pass in the constant to get that .jpeg file location. So this line of code returns a URI that we can then use to store our image in. We're not actually going to store the image in it, we're just going to give this to the camera intent and it will store the image there. So how do we let the camera activity know that we want our image stored there? Well, we pass it to it in a bundle. Now when we launch our camera activity, it's going to look for a specific value in its extras bundle. This key is mediastore.extraOutput. And we pass an ImageFileURI as the value. Finally, to launch the camera activity, we call startActivity for results, pass in the camera intent, and pass it a request code, in this case just 0. Alright, now when the user takes an image and hits done in the camera activity will then send back a result code in activity result. Let's go down and override that method. To do this, we hit Control or Command N, go down to the override methods, hit enter, start typing onActivity, and find onActivity result. The first thing we do in onActivity result is check whether the request code was okay. So if the request code is equal to result okay, we know that the camera took a photo. The camera activity is not passing back that image directly, but instead it already stored that image at our image file URI location. So the next thing we want to do is pass that image file URI into a bitmap factory in order to create a bitmap for us. Since it's returning a bitmap to us, we can store that in a local variable. So finally, we have a variable that contains our image data. Let's get a reference to our image view and then set that image view's bitmap to the camera bitmap that we just created. Alright, that's most of the code that we have to write. However, there's one small problem. When we launch the camera activity, there's a chance that our main activity gets destroyed. If that happens, our image file URI will be null, and this onActivity result will cause an exception when it tries to access the value at image file URI. Destroying an activity can happen for many reasons. One of those reasons is rotating the device. When an activity is destroyed, its onCreate method gets called again. But before it does that, the onSaved instance state method is called first so that we can store or save any data that we wish to retain between when the activity is destroyed and when it's recreated. So let's store our image file URI in case our activity gets destroyed. To do that, we override the onSavedInstantState method, Command N or Control N on Windows, go down to Override Methods, type in onSaveInstance, and find onSaveInstantState. So in our onSaveInstantState, we were passed as a parameter a bundle called outState. By default, we can't store the URI in the bundle, we can only store basic types. So what I'm going to do is convert the URI to a string and then put that in our bundle. Now that I have the image file URIs as a string, I'm going to pass that into the bundle. Alright, now I'm storing the image file URI string in the bundle under the key file URI key. Well, this is problematic and buggy because when I go to pull that out, I have to name the key exactly the same. If I misspell it, the value will come back as null. So to ensure that the key stays the same, I'm going to refactor that into a constant. Highlight the string, right click on it, go up to refactor, up to extract, and over to constant. This will make a constant out of that string. The defaults are fine in this case, so hit enter, and Android Studio converted that into a constant. Alright, so we just handled the case that when our activity is destroyed, we're saving that image file URI as a string, putting it into that bundle, and then continuing on with the activity lifecycle, whereas the activity will get destroyed and then recreated. When it's recreated, we want to pull this string out of the bundle, recreate our URI, and set our member to that value. So to do that, we go up to the onCreate method, and if you notice in the onCreate method, we're passed in SavedInstantState as a parameter. We can check to see if this is null, which means this onCreate is being called for the first time, or if the SaveInstantState has a value, that means our activity was previously destroyed and recreated, which means in our case, we have data saved in our bundle we can then extract and use. So in order to see if we have extra data in our bundle, we're going to make sure that this bundle is not null, and if it's not, pull out that extra data. So once we ensure that our saved instance state is not equal to null, we can pull out that data. Using the same key that we used to store our data, we can extract that data from the bundle. Now we have a reference to the file location as a string, but remember we need to turn that into our URI so that we can store it in our image file URI member object. So to do that, we create a new object of type file. We then use that to pass it into the URI to get our final URI object. Our URI constructor requires that we pass it a file. So we do new file, and this constructor takes a string. Well, our string file URI will work in this case. So now when onCreate's called, and our saved instance state is not null, we can pull out our value as a string and reconstruct our URI object using that string. However, there's a chance that our activity is destroyed without ever having to have this information stored. So we want to do one final check to make sure that our file URI string is not null before trying to create a new file and then a URI from that. Okay, it's always good to check for null, especially when pulling things out of bundles. Let's go ahead and run and test our code. You can see here we have our application with our single launch camera button, and below it we have an image view. The image view doesn't have a bitmap in it yet, so you don't see anything. Let's fix that. Alright, so we check to make sure that our saved instance state is not equal to null. If not, we pull a file URI string out of our bundle. We use that string to then reconstruct our URI. Alright, now we have our application with our camera button, and below that, an image view. The image view doesn't currently have an image in it, but let's fix that by taking a photo. Click the launch camera button, wait for the camera to appear, and you can see that this is the default camera. You can set your webcam to actually take a real photo, but this is fine for now. Click the camera button, hit the checkbox, and you can see that our image is displayed in our image view. Alright, and there you have it. Let's make one small tweak in order to enhance the user friendliness of our application. It'd be great to have a placeholder image until the user is taking a photo. That way the user knows that there's supposed to be an image that gets displayed in that image view. To do this, we go back to Android Studio and edit our layout. Alright, let's set a default image for our image view. You can do this in a number of ways. If you have your own, feel free to put your own in, but I'm going to use a system icon that Android actually provides for us. To do this, select the image view, scroll down to Source, and click on this little button here. Android Studio will bring up a resource chooser. I'm going to select System, select in this box here, and start typing in app_icon. The system default app icon is an Android. So let's go ahead and choose that. Go down to OK, and you can see now that our default image is now the Android. Let's run our application again. Alright, when we launch our application, you can see the default image is the Android. Launch camera, take a photo, hit OK, and you can see our Android is replaced with the image that we took. Alright, I hope you found this tutorial useful. If you liked it, hit that like button. If you want to see more tutorials on Android, iOS, 3D, electronics, and more, subscribe to the Electronic Armory.